Welcome to Module 3 of the BigIP LTM Essentials web-based training course. In this module, we will explore the different load balancing methods available in BigIP LTM and how to configure them. Note that this course assumes an intermediate level of TCP/IP networking knowledge. See the course overview module for more details. This course contains audio narration. In Module 2, Bob, our fictitious IT administrator, newly hired by Termmark Limited, configured several virtual servers and pools on BigIP, and used the default load balancing method of round robin. However, because the hardware of one of the servers in his pool is much newer than the other servers, it processes traffic more quickly. Therefore, the round robin load balancing method may not be the right one to use. In this module, Bob, and you, will explore other load balancing alternatives and when to use each one. Module 3 contains 4 lessons. Lesson 1 presents the various load balancing methods available within BigIP LTM. Lesson 2 explains the differences between load balancing by member and by node. Lesson 3 explores the priority group activation feature. And finally, Lesson 4 demonstrates how to configure the different load balancing methods. Lesson 1, Load Balancing Methods. After completing this lesson, you will be able to list the BigIP LTM load balancing methods and describe how each method works. BigIP LTM offers a variety of load balancing methods to choose from. There are 2 static load balancing modes, round robin and ratio, that do not take server performance into consideration. The other modes are least connections, fastest, observed, predictive, and dynamic ratio. These modes are considered dynamic because each one takes server performance into account in some way. Let's take a look at how these different modes work. Round robin is the default and probably the most commonly used load balancing method. Using this method, BigIP evenly distributes client requests across all available pool members. It is important to know that BigIP distributes requests between available servers only. Server availability is determined by the administrator and monitor status of both the node and the member. These concepts are covered in more detail in later modules. Let's examine the round robin example for a moment. Suppose server 4 has been marked offline or disabled by a monitor or an administrator. Using the round robin load balancing method, BigIP distributes client requests evenly across the remaining available 3 servers. The ratio method is appropriate to use if some pool members are more powerful than others. In this example, the ratio is set as 3:2 to 1:1. As a result, BigIP sends 3 times as many requests to server 1 and twice as many requests to server 2, as compared with servers 3 and 4. Remember the problem Bob was grappling with? He had one server that was much faster than the others. After reviewing the available load balancing methods, he chose to use the ratio method, knowing it would allow BigIP to better utilize his more efficient server. So what really happens in ratio load balancing? As requests are processed, all available members are given 1 client request. Once that has occurred, members with a ratio of 2 or greater are given a request, then 3 or greater, and so on, until the member with the highest ratio has been given the number of requests equaling its ratio. Then the whole process starts over again. Remember that both ratio and round robin are static load balancing methods. This means that if a server with a higher ratio is available, it will still receive more requests than the other servers, even if its performance is slower than the others. If you want to consider server performance, you should use one of the dynamic load balancing methods. We will discuss these in just a moment. But first, let's test your understanding of the ratio load balancing method. The least connections load balancing method uses the current connection count to decide where to send the next client request. Assume the current connection counts are as listed. The next connection will go to server 1. Now server 1 and 2 have equal counts, so BIG-IP will round robin between them. Assuming connection counts stay as shown, now servers 1, 2, and 3 all have equal counts, so BIG-IP will round robin between all three. Least connections is appropriate for many cases, but may be most relevant when the client connection length varies significantly and round robin could result in uneven loads. The load balancing method, known as fastest, uses the outstanding layer 7 requests to decide where to send the next client request. You might have assumed the fastest load balancing method used response time to make a decision. But what response time should be used? The response time to a ping does not take into account how fast a web server at port 80 will respond. And the SYNAC response to a SYN for port 80 does not take into account how fast the backend database server will be able to populate the content of the web page. These are two examples why fastest load balancing method uses outstanding layer 7 requests rather than response time. In the example shown, if server 1, 2, and 3 have equal numbers of outstanding layer 7 requests, then BIG-IP will round robin between them. Notice that server 4 may not be used until its outstanding layer 7 requests reach a similar volume to the other servers. The observed load balancing method is basically ratio load balancing, but with a ratio assigned by BIG-IP. The ratio assigned to each member is based on the current connection count. Servers with a lower than average connection count are assigned a ratio of 3. Those with a higher than average connection count are given a ratio of 2. Based on your understanding of ratio load balancing, you know more requests will be distributed to the servers with lower connection counts. These ratios are dynamically reassigned by BIG-IP every second. In our example, if servers B and C have lower than average connection counts, they will receive more requests. The predictive method is similar to observed, but assigns more aggressive ratio values. Servers with a lower than average connection count are assigned a ratio of 4, and those with a higher than average connection count are given a ratio of 1. This means 4 times as many requests will be distributed to the servers with the lower connection counts. Again, these ratios are dynamically reassigned by BIG-IP every second. In this example, servers B and D are the ones with lower than average connection counts and receive more requests. Note the ratio numbers mentioned for observed and predictive were used as examples to explain the differences between these two dynamic load balancing methods. On the next several slides, let's take a minute and test your understanding of the load balancing methods discussed to this point. Lesson 2, Member versus Node. After completing this lesson, You will be able to explain the differences between load balancing by node and by pool member. You will also be able to explain when you would use each approach. BIG-IP can do load balancing by pool member or node. When deciding which approach to take, the key question to ask is this: do you want BIG-IP LTM to make a load balancing choice based on pool member statistics or node statistics? If you recall, a typical pool member contains both an IP address and a port, whereas a node contains only an IP address. Therefore, if the administrator chooses load balancing by node, BIG-IP will take all transactions for that IP address into account when making a load balancing decision. On the other hand, if the administrator chooses load balancing by member, BIG-IP makes the load balancing decision based on the pool member port at that IP address. The next few slides present examples that will help illustrate the concept of load balancing by pool member or node. Lesson 3. Priority Group Activation. After completing this lesson, you will be able to explain the Priority Group Activation feature, as well as the purpose of a fallback host. In addition, you will be able to describe when to use each one. Bob's SE described that these features help automate how BIG-IP handles situations of less pool members available than are needed. Bob thinks one of these features might have assisted with an outage to Termmark's website a few weeks ago, so he's eager to learn more about them. Priority Group Activation allows the BIG-IP administrator to designate preferred and backup sets of pool members within a pool. This feature is often used to assist meeting client traffic demand when too many servers are unavailable. Take a look at this diagram. As you can see, all 6 servers are members of a single pool. Bob decides 2 available servers is enough to handle client traffic loads. Just to be sure, though, he decides to use 3. These 3 servers then should be the first to receive requests. Priority Group Activation makes this behavior possible. Bob configures 3 servers with a priority of 10 and configures the others with a priority of 5. If Priority Group Activation is set to 2, BIG-IP will use available members with the highest priority number first. It will then add all pool members at the next lower priority level until a total of 2 available members is obtained. In this case, if at least 2 priority 10 pool members are available, those servers will receive all the requests. But let's suppose 2 of the priority 10 pool members are marked offline. Since this means only 1 priority 10 member is left, we have now fallen below our minimum of 2 available pool members. BigIP then adds all available members at the next lower priority number until at least 2 are obtained. In this scenario, load balancing occurs as shown. If another priority 10 member becomes available, BigIP no longer uses the priority 5 member. The fallback host feature, which is designed for the HTTP protocol only, comes into play if all members in a pool are unavailable. Using the fallback host feature, BigIP sends an HTTP redirect to the client rather than sending no response at all. Let's take a minute and see how well you understand the priority group activation feature. Lesson 4. Configuring Load Balancing. After completing this lesson, you will be able to configure the different load balancing modes and appropriately set the ratio and priority numbers for your pool members. You configure the different load balancing methods within the pool configuration page, which is located in the local traffic section of the web configuration utility. Notice that most load balancing methods allow you to choose between member and node. Keep this in mind when making your choice. You also configure priority group activation in this same location. You can set the ratio and priority for each pool member by selecting each member and then configuring it, or you can set these values when you initially create the pool. Note that the ratio number within the pool is only relevant if the selected load balancing method is ratio, member, not ratio, node. If a load balancing method other than ratio, member, is chosen, such as round robin shown here, the ratio numbers would be ignored. If you choose a ratio, node, load balancing method, you must set the ratio within the node as opposed to within the pool member. Again, let's take a minute to test your understanding of BigIP LTM load balancing methods. This concludes Module 3. You should now be able to list and explain the different BIG-IP LTM load balancing methods, explain the difference between load balancing by member versus node, describe the priority group activation feature, and configure the different load balancing modes. It is now time for you to put everything you've learned into practice. By completing the labs associated with this module, you will solidify the knowledge you have gained. At the conclusion of the lab, the student should have configured a pool with ratio load balancing and driven client traffic through the virtual server and pool, and configured and used priority group activation within a pool from the lab registration page. You can also access the PDF file that contains the lab instructions. When you've completed the lab, be sure to answer the lab review questions, also contained in the PDF file. Click the arrow at the bottom of the screen when you're ready to continue. F5 Networks thanks you for attending this web-based training on BIG-IP. In case you're not able to do the lab right away, you